Greetings. Today's lesson is an extension of logarithms on 4.3. This is day 2 of 4.3, and what we're looking at today is the graph of logarithms. And the first thing we want to do is simply look at the y equals log base a of x when a is greater than 1. So generally speaking, this is what the graph would look like. We would have an x-intercept of 0, 1, and there would be no y-intercept. And the reason is because the vertical asymptote exists at x equals 0. That is where our vertical asymptote would be for a logarithm, because remember, the log can never be 0 or negative. It has to be greater than 0. So that makes our domain 0 to infinity. We also learned last time that the range is the same as the domain of the exponential because they're inverse functions of one another. That also means that we have a vertical asymptote but not a horizontal asymptote. So it's just the opposite between exponential and logarithmic functions. Okay, so shifts in logarithmic graphs follow the exact same rules as the other graphs that we have studied this year. So if we look at the first one here, sketch the graph of each of x equals negative log base 4 of x minus 3 and state the translation. Well, if you remember, we can't graph this on our calculator because it has a base of 4. But we can use the change of base formula, change of base, that's what we did in our lesson last time. We take the log of x, negative log of x minus 3 all over the log of 4. And then we just can pick some numbers and plug them in. And you can see that if we pick x to be 4, you get 0. And because the negative log of 1, because if I put 4 in there, 4 minus 3 is 1, the log of 1 is 0, 0 over the log of 4 is 0. And then we have some other numbers too, like 7, looks like it's about negative 1. We can go to our graph on our calculator, probably even easier. So if we just elected to graph this, we could find the table of values very simply. So we could go negative log of x minus 3, close it, divided by log 4, and zoom 6 it. And then we can kind of see that we're going to have a vertical asymptote at x equal 3, and that's because of this right here. We can also see that the domain is going to be 3 to infinity. Now I'm going to use my table quick and just see if I can find some numbers. 3.5 is 0.5, so that's on there. And we can see that, and then there's 4, 0, and there's 7, negative 1 is a point, and then we just have a lot of other points. 11, negative 1.5, that's right there. So we can kind of see what's going on from looking at our calculator. Negative 1.5, etc. Okay? Now, there's our graph. Now, what's the domain? Well, is that the same problem? Yes. Well, the domain is simply found by setting what's in the log greater than 0 because it can't be negative. So x is greater than 3, so it's 3 to infinity. We know the range is always negative infinity to infinity of logarithms. There is no y-intercept again, as we can see. The x-intercept in this case is 4, 0, and we can look at our calculator and determine that for sure, and it's 4, 0. There is never a horizontal asymptote when it comes to logs, but there is always a vertical asymptote, which is x equals 3. It comes from right there. So there is all of our information with our graph. Okay. Now, what about log base 6 of x plus 1 plus 4? Well, the plus 4 is going to move it up 4, right? Our domain is affected by this, and x plus 1, so we know that it's going to be greater than negative 1. So there's our asymptote, which is negative 1. So if we graph this thing again, we're going to go log of x plus 1 divided by log of 6. That's the change of base formula. And then we're going to add 4 at the end, hit zoom 6. And sure enough, that's the graph we get. Now we want to pick some x's and y's. Best way to do it is get on our calculator. 5, 5 is a point right there. What about 0? Looks like 0, 4, doesn't it? Yep. 0, 4 is a point. So there's our y-intercept. That's really about all the points we need. We have a lot of other points on here, but they're decimals as I'm looking through my calculator. And they're not good decimals either, as in they're easy to plot on here. So there's your graph, okay? Now we sketch the graph. Now let's state the it says state the translation. So this is going to be up 4 and left 1 because of, can't spell left, because of this. That tells us left. This tells us up because it's inside with the x. So we do the opposite. Okay, well the domain then is affected by, we already did it up here, x greater than -1. So -1 to infinity. The range, as always, the y-intercept we determined was 0, 4. The x-intercept, oh boy, we didn't find that, did we? So let me see if I can scroll down here and find it. Where is x? Where is x0? Oh boy, that's a tough one. Can't do it on my calculator as far as the table goes. Boy, I guess I can put 0 in there, can't I? So log base 6, so this would be log of 0 plus 1 over log 6 plus 4. Nope, sorry. That's the wrong way. It'd be 0 equals, doesn't it? Doggone it. So 0 equals this. And we got to find x. Okay, well we would subtract 4. Let's just see if we can do this. So log base 6 of x plus 1. Oh, sure. We can we can do this. So change this to exponential, which would be 6 to the -4 equals x plus 1. And then subtract 1. There's our x. Ooh, boy. So 6 to the -4 minus 1 is -0.99922 and a bunch of other stuff, comma 0. So there's the x-intercept. Almost -1, but not quite. Because it can't be -1 because it's a vertical asymptote. So I probably ought to say x equal -1. And again, there's no horizontal asymptote there. And then the last one is a natural log problem. No problem at all, really. We're going to graph this so we can get that graph there, right there that we're looking at. So the natural log of x minus 3 plus 1. The translation then is what, people? Right 3, correct, and up 1. So the graph, again, looks like it's cut off. It is not. It continues to go down because we have an asymptote at x greater than 3, don't we? Or 3. So our vertical asymptote is x equal 3. So that limits our domain to 3 to infinity. Our range stays the same, as always. There is no y-intercept. We might have to calculate the x-intercept. There's no horizontal asymptote. So if we're going to find the x-intercept, we're going to have to do this, as we did earlier. So subtract 1, So we're gonna go -1 equals the natural log of x minus 3. Remember, that's an e. So e to the -1 equals x minus 3. So we're gonna add 3. There we go. That's x. So e to the -1 plus 3. So 3.368 if we round it. So 3.368 comma 0. That's this point right there. 3.3680. Kind of cool. But we can do a little calculating by changing it from logarithmic to exponential. Enjoy.